Okay, this lesson is on adding and subtracting rational expressions. Okay, so how do we add and subtract rational expressions? In other words, fractions. Just a reminder that when we add and subtract, it's a little bit more challenging than multiplying and dividing because we need a common denominator. This first problem already has one. So when we add and subtract, once you find a common denominator, the denominator stays the same and you add the numerators. So this would be 4/5, and then you should try to reduce. 4/5 is already reduced, and you're done. But it's a little bit trickier if you don't already have that. So then you need to say, what is the least common multiple, or the common denominator between 4 and 6? The smallest number that they both go into is 12. So you're going to say, well, what do I need to multiply this first fraction by to get that? And that would be 3. So I multiply by 3/3, because 3 times 4 is 12. It's okay to do that because 3 divided by 3 is 1. Anytime we multiply anything by 1, we don't change its identity. It stays the same. The quantity stays the same. So I multiply by 3/3. And over here, we would multiply by 2/2, since 6 times 2 is 12. So that would give us, the first one would give us 3/12. And the second one would be 10/12. And then I can subtract now that I have a common denominator. I know that's going to stay the same, so there's 12. 3 minus 10 is -7. And then I would try to reduce. -7/12 is already reduced. So there we go. That's how we add and subtract fractions, as a quick refresher. All right, so when they are now polynomials potentially, what do? Well, we rewrite the problem using common denominators. This may need that you might have to factor a denominator to see what you'll have to do to get a common denominator. Step 2, then combine the numerators and keep the denominators. And then lastly, if there's any simplifying needed, go ahead and do that. Okay, so let's take a look at what this might look like. Here's a problem where we already have a common denominator. So these have 4a squared as my denominator. So I can leave that there. And then I want to look at the numerator and add or subtract. Well, I'm adding this time, and these are both like terms, so I can put them together. Remember, you can only combine like terms. So I'm going to put these together, and this is just going to be 18a. And then you want to try to reduce. Reduce your coefficients. 18/4 is 9/2 reduced. And then they both have an a in common, so I can take an a out of the top and an a out of the bottom as well. So I'm left with 9/2a. That's it. That's already reduced. Done. Okay. So then on this one, you'll notice common denominator. Great. So I have n squared plus n minus 6. And then I'm going to subtract this time. Remember, you're subtracting. So I go n squared minus, well, there is no n squared in this polynomial. So excuse me. I'm just going to say, there we go, n squared. And then, okay, now I'm going to go 3n minus n, which is 2n, because I'm subtracting. All right. And then I have -7 minus 1, which is -8. Okay, now I'm going to factor those. So if I factor the top, two numbers that multiply to be -8, but add up to be 2 would be +4 and -2. On the bottom, two numbers that multiply to be -6, but add up to be +1 would be +3 and -2. All right, now you'll notice I can simplify a little bit. These cancel out, so I'm left with n plus 4 over n plus 3. And that's my final answer. There we go. All right, let's try one more with a common denominator. Okay. So I have a common denominator. Let's just write 6k squared, there we go, minus 5k plus 1. On the top, we have 13k squared plus 1k would be 14k squared. And then I have negative 9k plus 2k is negative 7k. Okay. Now I would need to factor both of these to see if there's anything in common. So I'm going to factor the top. I get 7k is my GCF. I take that out. I'm left with 2k minus 1. Okay. And then the bottom, I already factored a bit here. I'm just going to show it to you there. I'm going to write without the 6 in front, right here. And then 6 times 1 is 6, so that goes right here. Two numbers that multiply to be 6, but add up to be negative 5. Be careful. It would be k minus 3, k minus 2. And then put your 6, your leading coefficient of 6 underneath there and reduce. You get k minus a half and k minus a third. And then slide those 2 and 3s in front. So I have 2k minus 1 and 3k minus 1. So I'm going to write that up here. 2k minus 1 and 3k minus 1. Okay, so now I can look at what do I have in common? Well, these are in common, right? And then what I have left is just 7k over 3k minus 1. And that's my final answer. Done. Okay, so now that we have problems where we're adding and subtracting with common denominators down, let's talk about, all right, what if they don't have a common denominator? How does this work? All right, so let's start relatively simply with, I don't know, something like this. You can see I got a 2x and a 3x. Well, they would both multiply into 6x. So that means I want to multiply this first part by 3 over 3, and then this one by 2 over 2, so that I can get a common denominator of 6x. So then on the top, I'm going to have 45 over 6x on the bottom. And then over here, I'll have 32 over 6x. Okay. So now if I subtract that, I get 13 over 6x. That's reduced already? Done. Okay. So that's kind of how that works. But it's not always that simple. So sometimes it'll get a little bit harder. We're going to try a couple of other ones here just to make sure. But sometimes you may have to factor the denominator just to make sure that you're in good shape. Now, you'll notice, I'm going to rewrite this. The denominator, there's a 5 here that I can factor out. So this would be k minus 2. Okay. Now, I see that my common denominator then, well, they both have the k minus 2 already. So I just need to have a 5 on this one. So that means I'm going to have to multiply this second equation by 5 over 5. So I can get that 5 in front. Okay, so 5, k minus 2, put the parenthesis there. K squared plus 16 there. On the top over here, we have 4 times 5 is 20. And then on the bottom, we would have 5 parenthesis k minus 2. You can see those are the same. Okay. So then, this would be k squared. And then I have 16 minus 20, which is negative 4. And then the bottom would be the same. Okay, but now this top is difference of 2 squares, so I'm going to factor that to k plus 2, k minus 2. And then 5 over k minus 2. These cancel out. So I'm left with k plus 2 over 5 as my answer. So you can see a little bit trickier, but still not too bad. You just got, if you're good with your factoring, it makes it a lot easier. Hopefully the factoring refresher helped you out. Okay, so I'd like to do a few more of these. I have 4 more to just make sure that we're okay. So again, if you don't have a common denominator, you may need to factor the denominator to just make sure you see what's going on. So that's what I'm gonna do. Let's change this. This first one is fine. But the second one, I want to factor 2 numbers that multiply to be 24, but add up to be 11 would be 8 and 3. And then I have this on the top. So that means I'm going to need to multiply this first one by y plus 3 over y plus 3. Okay. All right. So then let's see. This first one I'd have, well, I know the denominators are going to be the same now. So I'm just going to write that. On the top, though, I do have to distribute it to both of these. So I have 7y plus 21 plus this. Okay. Oops. All right, now put them together, right? So I would have 7y plus 21 and 35 end up giving me 56. And then on the bottom, I'd have y plus 8, y plus 3. Okay. This would be 7, y plus 8. Denominator is there, and then these cancel. So my final answer for this one would be 7 over y plus 3. There we go. Kind of a lot going on there, but a good problem. If you're, again, your factoring being strong really helps. Okay, let's try another one. Okay, this one maybe, instead of rewriting everything, I'm maybe just, this is the same as m plus 2, m minus 2 on the denominator here. So you can see on this second denominator, I have n minus 2. I'm missing the m plus 2. So I'm going to need to multiply both the top and the bottom by m plus 2. And then I would have a common denominator. All right, so copy this, m plus 2, m minus 2, plus, distribute the 2 over here. This would be 2m plus 4. And then I'm just going to keep this in the same order, m plus 2, m minus 2. Okay. If I combine everything on the top, 5m plus 2m would be 7m. 6 plus 4 is 10. M plus 2. M minus 2. Okay. Factor the top. 2 numbers that multiply to be 10, but add up to be 7 would be 2 and 5. So these cancel, and I get m plus 5 over m minus 2. Whew. Okay, let's try a couple more. Okay, so sometimes you won't have any factoring to do. So then you can just multiply each one by the other denominator. So in other words, this first one here, I'd want to multiply it by w minus 7 over w minus 7. And then this second one, I'd multiply by w plus 1 over w plus 1, so that I get my denominator to be w minus 7 times w plus 1. Okay, so then let's do a little bit of that. Oops. It's kind of a lot of writing sometimes, but it's best to write it out so you don't miss anything. So now I'm going to distribute the 5 to this first, both of these, right? So that would give me this. And then this one, 8 to both of these would give me 8w plus 8. Okay. If I combine like terms, I'm going to put the bottom down here already. I would get 13w, and then negative 35 plus 8 would be negative 27. And there's nothing I can factor in the numerator. The denominator's already done, so hey, there we go. We're done. So sometimes maybe not as much. Okay. All right, this one, again, it does look like I can do some factoring. So I'm going to factor out the 2 here. I get r plus 4. There we go. This is subtraction. Over here, factor out an r, and I would still get r plus 4. Okay, so I need the bottom to be really 2r plus 4. So this one here is missing an r in the front. This one is missing a 2. Okay, so I'm going to multiply this by r over r. And I'm going to multiply this one by 2 over 2. There's the 8. Okay, so this would be r squared, and then on the bottom 2r times r plus 4. This would be 16 over 2r times r plus 4. Okay, so I have r squared minus 16 over 2r times r plus 4. Well, the top there is a difference of 2 squares. That would be r plus 4, r minus 4. Okay, these cancel out. And so my final answer is r minus 4 over 2r. There we go. I hope that is starting to make some sense to you. You can go ahead and tackle this assignment. Don't forget to write it in your planner. Good luck. See you.